In continuation to the previous class where we could not end up with the relation of the Mach number and the velocity, no? Because the time was out, so we had to leave. And a recapitulation that we had said that sonic velocity, right? So we had said that sonic velocity, and from that sonic velocity we have defined that Mach number. So Mach number was nma, right, and that was the velocity of that to that velocity of sound, and ultimately we brought it to rather the tip velocity of the nozzle, right, tip velocity at the nozzle. So V0, P0, rho 0 at the nozzle, right. From there, what I remember that we had come to the level nma square is equals to 2 by gamma minus 1 into P0 by P to the power 1 minus gamma by gamma minus 1, right. This we had done in the previous class, right. Now, let us assume that Mach number is nma is equals to 1. What does Mach number is equals to 1 mean? That Mach number is equals to 1 mean that from the definition of Mach number, nma was v by vs, right, or v0 at the tip and by vs, that this is equals to 1. That means v0 is equals to vs, which means that when Mach number is 1, the velocity at the tip is velocity of the sound, right, velocity of the sound, that is what we get, right. And if it is less than 1, if nma is less than 1, then we call it to be, this is velocity of sound. And if we say that Mach number is less than 1, that means V0 by Vs is less than 1, that means V0 is less than Vs, right. That means velocity at the tip is less than velocity of sound. It is called subsonic velocity. And if nma is greater than 1, then this means V by or V0 by Vs, V0 by Vs is greater than 1, that means V0 is greater than Vs, that is velocity at the tip is greater than velocity of sound, and this situation is called supersonic velocity, right. So, that is what you remember in the previous class, which I said that if you are staying in area where there are Air Force region, and you might have seen that lots of Air Force planes are moving at very high speed, right, and when that speed is the speed of the sound, then we hear that. But if it is less than that or greater than that, then we don't hear it, right. And I said also one thing, that sometimes it makes boom, right, some sound like a boom, and this booming, and it is so severe that if you are staying there, that your windows and other things may shatter, or it may have some vibration, severe vibration, right, depending on how close it is. Then when this is changing is happening, that is supersonic to sonic or sonic to subsonic or the vice versa, then this booming take place, right. So this is a very great example of this supersonic, subsonic and sonic velocity, right. So we have now assumed that if the Mach number is 1, then what happens? So if we take Mach number here is equals to 1, that is NMS square is 1. So this is equals to 2 by gamma minus 1, right, into P0 by P to the power 1 minus gamma by gamma minus 1, right, or P0 by P to the power 1 by minus gamma by gamma, this is 1 minus gamma by gamma, this is equals to P0 by P, this is equals to, this 1 goes there, right. So this is, that means okay, P0 by P, let us write again, or P0 by P to the power 1 minus gamma by gamma minus 1, this is equals to gamma minus 1 by 2, right. So from this relation, or P0 by P to the power 1 minus gamma by gamma 1 plus gamma minus 1 by 2, right, that is, this is equals to gamma plus 1 by 2. So we can rewrite that P0 over P to the power 1 minus gamma by gamma is equals to gamma plus 1 by 2, right, or we can write P0 by P to the power gamma minus 1 by gamma is equals to 2 by gamma plus 1, right. This we can write easily. So we can also write P0 over P is equals to 2 by gamma plus 1 to the power gamma minus 1. In this case it will be inverse. So it will be gamma by gamma minus 1, right. This will be inverse. So gamma by gamma minus 1. So P0 by P is equals to 2 by gamma plus 1 to the power gamma by gamma minus 1, right. That if now we assume that gamma is equals to 1.4 for diatomic gases, for a diatomic gas, if gamma is 1.4, then we can write P0 over P is equals to 2 by 1.4 plus 1 to the power 1.4 by 1.4 minus 1, right. And let us see what it makes. So we have 2 by 2.4, 2 by 1.4 plus 1. So this is 2.4. So this is this to the power 1.4 divided by 1.4 minus 1, right. So this 1, this 2 and this 3. So this is equals to 0.528. So, this is equals to 0.528. That means P0 over P is equals to 0.528, which is nothing but the critical velocity. Right. So, this means this is nothing but critical velocity, and that tells that when the velocity is under critical condition, that is P0 by P becomes under critical condition, then the ratio of tip velocity to the inside or inlet velocity, that becomes equals to 0.521, right. So, we have seen that means when Mach number is equals to 1, right, when Mach number is equals to 1, then the pressure ratio becomes critical and the value is 0.528. When this value becomes 528, we can say that this velocity has become the velocity of the sound, right, because this is what we showed earlier, that Mach number is equals to 1 is equals to V0 by Vs equals to 1, or V0 is equals to Vs, right. Now, we have shown that P0 by P becomes critical when it is 0.528. So, corresponding velocity is V0 and that becomes critical velocity, V0 critical. So, that becomes the velocity of sound. So, under critical condition, the velocity at the tip when it is 0.528 of the pressure ratio of the outlet to inlet or tip velocity to inside velocity, that becomes 0.528, then it becomes the velocity of sound, right. This is a great thing which was developed earlier by the greatest scientists like Mach and others, right. So, we said that someday we will try to bring their photographs and some biography of some of the people who are really contributed to this field. Okay. So, for recapitulation, let us look into that. Let us look into that whole thing. For the sonic velocity, let us look into that. We had started with this, that sonic velocity is Vs, velocity of sound in air, is under root k by rho, where k is the bulk modulus of the medium. So, if it is air, then it is the bulk modulus of air, right. And also we said that k by k is the bulk modulus, that is by definition can be said del P over del V by V, that is the change in volume per unit volume with respect to the change in pressure, right. Now, it has been seen that change in volume per unit volume is decreasing as the change in pressure is increasing, right. So, as the delta P is increasing, the change in volume per unit volume for the air, that is the bulk modulus, that is decreasing. So, to account for this, the negative sign comes in, and that if we introduce, then we can say that del P over del V by V is equals to minus del P over del V by V, right, and this is equals to del P over. So, this V 1 by V can substitute as rho dV, right. So, this we have substituted and we have made minus dP over rho dV. So, this is possible because V is nothing but 1 by rho. So, we can write from there that if V is 1 by rho, therefore, dV over d rho, dV over d rho or dV d rho is equals to minus 1 by rho square, that is minus rho to the power minus 2. So, that means minus 1 by rho square, or dV can be written as, if we substitute, that dV can be written as d rho minus d rho over rho square, right. So, therefore, that bulk modulus K can be substituted with minus dP over rho times minus d rho by rho square. So, this minus goes off, this rho square, 1 rho goes off. So, this rho comes to the top. So, that is rho dP over d rho. So, K becomes equals to rho dP over d rho, or K by rho is equals to dP over d rho, right. Therefore, we can write from this definition Vs is under root K by rho. So, that can be written as under root dP over d rho, right, dP over d rho, because dP over d rho, that has become from this K is this. So, K by rho is dP over d rho. So, Vs is dP over d rho. Now, we also said that if the flow is taking place through adiabatic flow, that is, there is no heat loss or heat gain, right, there is no heat loss or heat gain if the flow is under adiabatic condition. Then we can also write that for adiabatic flow, PV gamma is equals to constant, or we can also write that P is equals to CV to the power minus gamma, that is equals to C rho to the power gamma, right, CV to the power minus gamma or C rho to the power gamma, right. So, we can write that dP over d rho is equals to gamma C rho to the power gamma minus 1, that is equals to gamma P V to the power gamma into rho to the power gamma minus 1. So, that is equal to gamma P rho to the power gamma minus 1 by rho to the power gamma, or this can be simplified as gamma P by rho. So, we write Vs as under root gamma P by rho when the flow is under adiabatic condition. So, that is a must, that flow is under adiabatic condition, that is, there is no heat gain or heat loss, or there is no heat flow into the medium. So, that condition PV gamma is constant, this we have to keep in mind, right. So, Vs has become under root gamma P by rho, right. Now, we define a new number called Mach number. So, Mach number is defined as, if it is written as NMA. So, this is a dimensionless number, and that is defined as the ratio of velocity over the sonic velocity, ratio of the velocity of that point or of that system over the velocity of sound, Vs, right. So, we wrote that Mach number NMA is V by Vs is V0 by Vs, that is, if the flow is also occurring through the nozzle. So, this we said repeatedly, but again that if the flow is occurring through the nozzle, and if the tip velocity of the nozzle is V0, corresponding pressure is P0 and corresponding density is rho. similarly inside is P, V and rho, then we can write that for the nozzle velocity nma is equals to V over Vs is equals to V0 over Vs, right. So, from there we also wrote that the velocity at the tip is V0 equals to Mach number times under root gamma P0 V0, assuming that the flow is occurring at the tip of the nozzle, right. So, this we finished in the previous class and that is a recapitulation. Then we squared up this V0 square is equals to nms square gamma P0 V0. So, we can write nms square gamma P0 V0 P0 and this should be V0, right. Gamma P0 V0 is equals to this V0 square. V0 we had written many times, that is under root of this. So, when square is there, so that under root goes out. So, gamma P V or into gamma minus 1, or in many cases we had written gamma P by gamma minus 1 into rho. So, that means this rho goes out, V comes on the top times 1 minus P0 by P to the power gamma minus 1 by gamma, right. So, this on simplification can be written that nms square is equals to 2V PV, right, 2 PV by gamma minus 1 into P0 V0 times 1 minus P0 by P to the power gamma minus 1 by gamma, right. So, this on simplification we can write nms square is equals to 2 by gamma minus 1 this one into P by P0 into V by V0, which can be substituted as P0 by P to the power 1 by gamma, because PV gamma is equals to constant. So, PV is equals to P0 PV gamma is equals to P0 V0 gamma, right. From there we can write that P0 by P is equals to P0 V by V0 is equals to P0 by P to the power 1 by gamma, right. So, this is substituted and then the remaining one was 1 minus P0 by P to the power gamma minus 1 by gamma, right. So, since it is there, so we can rewrite or we can rearrange as 2 by gamma minus 1 times this P0 by P, right. This is P by P0. So, if we make it is 1 inverse, so it becomes 1 by gamma minus 1. So, P0 by P 1 by gamma minus 1. This can be written P0 by P to the power minus 1. So, that minus 1 goes into there. So, this is 1 by gamma minus 1. So, P0 by P to the power 1 by gamma minus 1. So, into 1 minus P by P0 to the power gamma minus 1 by gamma. So, then Mach number square, this we can write to be equals to 2 by gamma minus 1 into P0 by P to the power 1 minus gamma by gamma minus 1, right. So, this was also done in the previous class. For recapitulation, we have taken it. Then we said if Mach number is equals to 1, right, for when V0 becomes equals to Vs, then Mach number becomes equals to 1, right. So, because NMA we said it is V by Vs, right, V0 by Vs. So, when it is equals to 1, then V0 is Vs, that is the tip velocity becomes the velocity of sound, right. So, if velocity of sound, so if it is that when V0 becomes the velocity of sound, then Mach number becomes equals to 1. So, if Mach number becomes equals to 1, then we can write that NMA is 1. So, NMA square here it was. So, it is 1 times 2 by gamma minus 1 times P0 by P to the power 1 by gamma minus 1. If you remember, we had this, okay, P0 by P to the power 1 minus gamma by gamma minus 1, 1 minus gamma by gamma minus 1 minus 1, right. So, this is, then we can rearrange, right. So, we can rearrange that this we had shown today, that this gamma minus 1 by 2, this becomes gamma minus 1 by 2, right, minus 1. So, that means gamma minus 1 plus 1, that means becomes gamma plus 1 by 2, right. So, that is what it has become, gamma plus 1 by 2, that is equals to P0 by P to the power 1 minus gamma by gamma. So, we can also write P0 by P to the power gamma minus 1 by gamma, that is equals to 2 by gamma plus 1. So, P0 by P equals to 2 by gamma plus 1, it will be inverse of this. So, gamma by gamma minus 1. So, 2 by gamma plus 1 to the power gamma by gamma minus 1. Now, if we say that the fluid is diatomic gas, then the value of gamma, that is heat capacity ratio, we can take as 1.4, and if we take 1.4, then this ratio P0 by P, that becomes equals to 0.528, right. Now, the implication of this is that the pressure ratio, when it becomes 0.528, earlier we also have shown and established that at that situation the pressure ratio is called critical pressure ratio, and also we have established earlier that at this pressure ratio of 0.528, the velocity becomes maximum, that is Vs is maximum. So, or rather V0, that is tip velocity, becomes maximum, and we also have shown that when this pressure ratio critical becomes 0.528, then the velocity of the tip, that becomes the velocity of the sound. That means that velocity is equal to the velocity of sound, and when it is, you can infer that when the pressure ratio becomes 0.528, then it becomes the velocity of sound, and it attains the velocity, that velocity at the tip attains the velocity of the sound when the pressure ratio becomes critical. And we also have shown earlier, at this point the discharge also becomes the maximum, right. So, when the velocity is maximum, when the discharge is maximum, then the velocity which it attains in air, then it is the velocity of the sound. So, this we can infer that when velocity becomes maximum, when velocity becomes discharge becomes maximum, then the pressure ratio becomes, pressure ratio means outlet to inlet, or critical or the tip velocity to the inlet velocity, that becomes 0.528, and if this 0.528 pressure ratio is attained, then all corresponding velocity or discharge becomes maximum, and the velocity attains the velocity of sound, and this is what is the sonic velocity, right. So, this we have given the example with the aeroplane also, right. So, hope we have understood this. Thank you.